When examining parallel circuits, it means that the load, all the different loads are going to be in parallel with the source, or the power source. Here's our power source. We're going to make a couple lines go this way. And it's always assumed that if we put a load across the circuit, another load across here, and even here, that we have the same amount of voltage that's going to be across each one of these different loads. Even in the application of running these, say, hundreds of feet in, say, this line out to another load, in the diagram it's still considered that this is just, there's not going to be any losses in the conductors, and the voltage that's applied across the circuit will be the same. For example, if I have 10-volt source here, across here and here, we're also going to wind up with 10 volts out across this branch, volts, 10 volts, and 10 volts out across this load. That way, for the purpose of the analysis between troubleshooting and designing a circuit, this is assumed to have a lot less loss than what might be assumed if it were, say, hundreds of feet long, each one of these conductor lines. So, as we're looking at the circuit, if we put 10 volts across this line, because the wires actually are going to be connecting to all of these at the same types of points, this will have 10 volts across this load, be 10 volts across this load, and 10 volts out across here. If we change it, it'll be the same out across each one of those. Then we can go in and do the individual analysis between what's the value of the resistance of the load itself, the amount of the branch current that's going to be going up through each one of these. So regardless of what resistance is setting out here, or the load requirement, these will determine how much current goes through each individual branch. But the voltage is always assumed to be the same across each one of